Alright, so this tutorial is a summary of what we discussed in class with the exploration of a full wave rectifier, taking a look at the background, why we want a full wave rectifier going from AC to DC, the issues with using a single diode, and then how we can eventually get around that using a clever combination of diodes. All right, so a little background. AC electricity is a dominant mode of electricity transfer because it can easily be produced in quantity. All right, we can get gigawatts and gigawatts from power plants, and we can transform with transformers to very high voltages to minimize heat losses as typified by I squared R, thus allowing transfer of power of great distances and eventually be stepped down for safe usage in factories and homes. Okay, we have a little problem though with that, and many electron devices nowadays run off of DC current. So we want to be able to turn, at least in our home, AC into DC. All right, so we want an electronic component to rectify the current into one direction, hence the term rectifier. You go from AC to DC, two directions or multiple directions to one direction. So enter the diode. Okay, a new electronic device, very different than a resistor. So the symbol for diode is an arrow with a little straight line afterwards, and that's important because the left of the arrow is the positive side and then the negative side, meaning that current flows this way through the rectifier. And if current flows this way, at least conventional current, then we're going from positive to negative. Right? And this is what an actual diode may look like in a circuit. So diodes are biased in that essentially it has zero resistance in the forward direction. In other words, when we go from positive to negative, so that's why it flows that way. But it has infinite resistance when you try to go the opposite way from the negative side to the positive side. Okay, so if you only want current in one direction, you put a diode in there. If you put the diode against the grain, in other words, if you have a, let's say a circuit, a DC circuit that looks like this, and I put a diode like that in the circuit, okay, the charges, actually, that's okay. That's all. No, let me go the other way. So if I have my diode like this, okay, I put little junctions there. The current wants to go this way through, and there's an infinite resistance, if you will, blocking it, so there will be no current whatsoever. If I flip the polarity of either one, then I'll get a constant DC current. Okay, so how can we use it? Well, you simply place it in series with a load when you have an AC. So if I have AC input where I have my voltage changing with time, where I have positive and then negative at some frequency, when we have it run through the diode, okay, it can only go in one direction during this part of the cycle or this part of the cycle. During the negative part of the cycle, there will be no voltage or current at all, because when if I call this the positive and the negative side of my variable AC source, when we have this polarity, then the current will go around in a clockwise. When it flips polarity like this, it can't go anywhere because the diode has infinite resistance in that direction. So our output will look as shown here. We have a positive voltage that changes with time, similar to the same one before, but during the negative phase of it, there's nothing, and then we're back to the positive phase, etc. So notice that the bottom half of the wave is lost, thus half the power is lost. Okay? We can't have that. So this setup, where we go from AC to DC, but we lose half of our power, is called a half-wave rectifier, and it is simple and fairly effective, but we want more than that. We want to have our whole power. So we want to be able to build a full-wave rectifier, also known as a diode bridge. Okay, and it's a nice little combo of diodes that does two things. It rectifies the situation. All right, and I mean that two ways. It straightens out our issue. It gives us a direct current, and it will give us full power Okay, or actually it gives us one current and it keeps the full power. Okay, that's the second thing. So what does the output look like? So we have input of AC where we have positive and negative. We go into a mysterious combo of diodes, and I don't reveal it yet because we wanted to explore first. But our output through the load looks like this, where we have only positive current, and since it's always positive, that means it's in one direction. It just goes from peak to peak to zero without any gaps between it. Okay, so how do we do that? How do we set that up with diodes? Well, let's reveal on the back. And this is what you would have found, or some of you found with the simulation. So let's make sure we understand all the parts, because you need to be able to recognize all the parts and then even trace them and show direction of current, etc. So we have an AC input right here, where we're going to say, at least at the beginning, our positive terminal is here, then our negative. Okay, and then that's going to flip every half cycle, so maybe I'll put a negative here and then a positive here to indicate afterwards, because I'll use some color coding. We have right here this diamond is where we're going to put our rectifiers, and I'm going to add them in one at a time to develop the circuit so we can understand how we meet all the criteria. But importantly, we have a load out here, okay, where we have DC output. Our goal is to take the alternating current that's going through the AC and get direct current that is, in this case, going to be down through the load. So how do we configure the diodes to do that? Well, let's start at the beginning. Let's say at the beginning this top terminal is positive, so we're going to have current going this way. So I want to go to the load right here, events right there, so it makes sense I'd go from A to B. So to make sure the current can only go this way from A to B, because remember, the current's going to be constantly changing direction with the AC input, I'm going to put my first diode right there. So I'm going to put, this is my diode symbol indicating that this is the positive side, this is the negative side, and so we're going to go from A to B. Our current is going to continue on, go through the load, and now we got to complete the circuit. This is a bridge right here, that little curve, so we're not connected there. We go through, and now we got to head back to here. So how do we get from here to here? Well, it would make sense that we go from D to C. So I'm going to put another diode right there, and then we complete the first half of our loop. Okay, so our current is going from the positive to the negative, and we've headed down through our resistor. If we were to reverse the current so that this is now the positive and this is the negative, I'm not going to do anything now, but if I try to follow this backwards the way I came, right when I get to right here, I hit a dead end. It does not allow any current flow in there, so this is not going to reverse itself and go up through the resistor. We don't want that. So that's why we use diodes there. It allows the current to flow in one direction, in this case kind of like clockwise, but when the AC switches direction, it cannot go counterclockwise. So we got to put in two more diodes to allow it to go counterclockwise, yet still go down through the resistor. So how do we do that? Okay, so now we're going to start here. This is now a positive a half a cycle later. So we're going to head this way. We got to go up. We got to go here. We can't go down this road because the diode's there, so I have to go up and to the left. So it makes sense that I would put a diode right here. Okay, so where we go from, there used to be a C there, C to B, and now I am going to go through the resistor once again. Notice we're going down. That's exactly what we want. So on both cycles, we're going the same direction through the resistor. And now we just got to get back to the negative terminal. So when I get to D here, okay, you might say, well, we would follow the blue diode here, but we don't want to go back to the negative. That's where we started. So we want to go to the other terminal. So we would put a fourth diode right there, and we complete the circuit there. So we have a diode bridge of 4 diodes that are configured in a way that if you look closely, you see a pattern developing. Okay, so to sum up what we just talked about there, okay, so we want a full loop. That's what the blue one is about, passing through of the resistor for the first half cycle. And so if you follow what I did there, we went from A to B, then we went through the resistor, then we went following the blue path D to C, and we completed it. Then for the other half cycle, we want a full loop from the negative to the positive AC terminals while passing through the same resistor in the same direction. We don't want to go the opposite direction. That would defeat the purposes of a rectifier for the second half of the cycle. So if I follow the red, right, do that again, we started with C, okay, then it went through, went from C to B, went through, came to D, and then went to A. Thus we have DC outputs, exactly what we want. So study this very, very carefully, and note that on our output right here, okay, we don't even have to have a resistor there. This is the positive side, this is the negative side. Okay, and we'll explain how we can recognize that when it's not made obvious. Okay, so the positive, in fact, address it now. Note that the positive terminal of the output is at the junction of, right, the same sides, or the positive sides, the negative sides of the two diodes. And the negative terminal of the output is the junction of the positive sides of the other two diodes. So if you're not sure what I'm referring to, here is essentially the positive terminal, right? And so they are the junction of these two diodes, and we're on the negative sides. And then if I look at the junction of the two positive sides here, that would extend to our negative terminal. So that's how you can recognize which side is output is positive, which side is negative. Okay, and during each half cycle, current only flows through one set of parallel side diodes. In other words, if I look at the reds or the blues for our first half cycle, notice that the current flow, these two diodes right here and right here are going in the same direction, they're parallel, and then on the back end of it, they are also parallel to one another and going in the same direction. So that's another little clue as to how things flow. Okay, last thing. One little issue with the output of a full wave rectifier is that the output voltage or the current, okay, shifts. There's another word for it. I can't think it off to the. Okay, no, the word isn't shift. I can't think of the word off the top of my head. It's not smooth. Okay. I'll think of the word in class. In other words, if I look at this output, I get periods where there is very little current. So if you look at an oscilloscope, it kind of is wavy. It's not as smooth as we like. So we got to just address one more thing, and that is how we would smooth it. So one way to smooth output is to place our old friend, a capacitor, in parallel with the output. So if we go back up here, all right, if I place a capacitor right here, I will get a much smoother output because that capacitor will be constantly charging and discharging. And when it discharges, it helps fill in the gaps in the output. So if this represents the output with just the diode bridge, okay, if we put capacitors in there, then it'll take on more of this shape, which is kind of flatter. And that's what you want from a DC. There's not as many ripples in it. Okay, and then you can look at when the capacitor is charging, there's that little bump right here, and when it discharges, it fills in most of the gap, and that's important. Okay, so that's it for a full wave rectifier. Understand what its purpose is, and recognize how the diode setup, the diode bridge, allows for current flow for one half of the cycle, and then opposite current flow for the other half, yet still go through the load within the same direction.